Quantities. Whoops, we're on the wrong thing. So like boys and girls usually hear it, like for like college campuses and stuff, like what the ratio is. A proportion is a statement of two ratios being equal. Extended just means you have more than one or more than two. Scale drawing is like what you do on a map, or like a map. It's not the actual world, shockingly. It's just like a picture of the world, and then the scale itself is like measuring like, okay, 1 centimeter is like however many miles or something like that. Cross product, this is what we're going to be obsessed with this unit, is this guy. Woo! Cross multiplication. So we'll do that a lot. Those are all kind of, you know, these properties. ACT likes to throw these randomly at you, which is, you know, interesting. But it's just like you can mess with a proportion is essentially what this is. This first one is if you were to cross multiply this proportion. So like if you did A times D equals B times C, that's like still, all of these are just ways to mess with this, essentially. And they're all still like equivalent. So the first one's cross multiplying. If you notice the pattern on the second one, do you see they just like did the reciprocal of it? Like they just flipped them both. That's legal. Like you could totally do that. That's normal. This is like flipped. Maybe, or do you not believe me? We can do this. Like if you did 2 over 4 equals 3 over 6, you could write 4 over 2 equals 6 over 3. Like it's still the same. So you could flip a proportion, that's legal. This one is like, this makes more sense when we actually do problems. This is like if you could do A over C equals B over D. So you can like, I'll show you with problems, but this is like a cross kind of, I don't know how to explain. Like instead of doing, like before it was A over B, now it's A over C. So you can mess with this proportion by going A over C equals B over D. And then the last one's super messed up, I think. That's the weirdest one. You can add the denominator to the numerator, which is kind of a random thing, but like you can, and it's still like an equivalent. So like whatever the denominator is, if you add it to the numerator on both of them, it's still like equal. It's kind of weird. But anyway, I'll show you when we get to those. But it's just like a way to mess with a proportion. Okay, so these are like the first couple questions on your ACT. They'll give you like a chart or something. And they say write a ratio or what's the ratio of or something like that. Games won by the Hawks to games won by the Tigers. So this is more for like a notational thing, but like games won by the Hawks. You look at the table and you look at wins and then you find Hawks and you're like 16. So you write 16, or if you're going to put in a fraction, it would be the numerator. Okay, so the 2 is either the fraction bar, girls, okay, or a colon. And then games won by Tigers, so you look wins by Tigers and you're like 15. And then you can either write 16 to 15 or 16 to 15 with the colon. We don't usually deal with the colon just because we like mess with the fractions a lot, but it can be a thing. Number 2, ratio of the longer side to the shorter side. They're going to try to mess with you with the units. That's why I put this one on here, because you see how it's 40 inches to 3 feet. You got to like convert it. So because like a ratio technically doesn't have units. Like they're doing 1 to 1, like how many games won. So technically like units, you can think of it like it's canceling, but like a ratio doesn't have units. So like what you do is you have to convert it first. So I'm going to do inches because I don't want fractions to deal with. So like if I do 3 feet to inches, what is through 12 inches foot, right? So 3 times 12 to get 36 inches. So if you're going to do the ratio of the longer side, so the longer one is 40, even though, of course, the picture doesn't look like that because that's how ACT is. You're welcome, right? So you're going to do like 40 inches is to the shorter side, which would be 36 inches, and you can see like the units cancel out, you know. And you should reduce the fraction. So like, what is it, 4 goes in both? 10 over 9. So this would be the ratio, 10 to 9, or if you do the colon. The colon's a thing, but like I said, we don't do that as often. So that's all you do, change the, make sure the units match. So that problem's there for that one. Now you can actually solve equations with this. So a lot of them, they do surveys or tests or sample size, they usually do. 50 students driving to school and found 28 owned cars. And then like use this data to make a prediction about the rest of the school is essentially what they're doing. So what I do is I'll do 50 students driving. So I'll do like 50 students, or I'll just do say driving, how about 50 driving to 28 owning cars, right? So 28 own. And then this is proportional, okay, so we do the equal sign. It's proportion to the 755 driving. So you make sure it's in the right spot, because they are not talking about owning cars. They're saying the students are driving. So make sure you put the 755 driving on the numerator, and then predict the one who owns. So this would be X own. And now you might be, couldn't, like, what about the units and stuff? The units ends up canceling out. Like your driving units will cancel out and you're left with owning units. So it will work out when you do the math. But all this is just your cross multiplying. So you're going like 50x equals whatever that psycho number is, 28 times 755. Whatever that is. So 50, wait, I wrote it. What did you get? 21140? 140 divide. Yeah, so then usually they'll have you round because like people, you know, so you would say like, yeah, 423 owned cars. So they usually do like a sample of one ECT on there. So that's one type, okay. Okay. These guys, these are using the properties. Yeah, this is hard to see. So it's I'll just write it really big. A over B equals 3 over 4. And they're saying, if I mess with it, what should this equal? So if I say 4A, if I'm like using like how it's set up in here, what would it equal? So it's like, honestly, I don't memorize the properties. I just look for the pattern, if I'm being completely honest. So like here, if you look where 4 and A are, they like crossed multiplied, right? So then to get the other one, you just cross multiply. So you would do 3B. So it's more like figuring out the patterns. That's what I do for these. So like on the next one, they're doing A over 3, right? So they did A over 3. So then the next one, you just kind of follow how it goes, you know, like, so they did the numerator, so then just do the denominator, B over 4. Technically, that's what, number 3? But it's like, why memorize all that? You could just figure out the patterns. This is the weirdest one. This is the kind of goofy one. This, like, plus one, you know? So you kind of have to be like, what is happening, right? So here's A, here's B, okay, but then they have this random plus B on the top, right? So this is that weird one where they added the denominator to the numerator. So like if A and B stayed, you're going to keep 3 and 4, right? If I'm following the vibe of what it was. And then they have a plus sign because, you know, plus. And then they added the B, which is the denominator, which is 4. So then you would simplify it to some 4s. So C is the weirdest one, but if you follow patterns, you should be able to figure it out. These A through C are just like hardcore algebra problems. So you're just gonna straight up cross multiply. I just put the ones that people mess up. And I'm gonna show you little tricks. Because like if you can simplify these, it's just like easier on your life. And because you're accelerated, I think you can handle it. So like this first one, gosh, I'm not doing too well today, is you're just doing straight cross multiplying. So you're going 5x times 8 equals, and then you go 4 times 35. You don't have to show all this work every time. I'm just like showing it for your notes. But like what this ends up being is 40x equals, and then 4 times 35 is 140, I think. Right, 120 and 20, yeah. 140. And then you divide out the 40. And don't be afraid of decimals anymore. So like in this semester, a lot more decimals. So don't be freaked out by that. Okay, so hopefully that one wasn't horrible. And then so this is like my trick for part B. Save more of your life by reducing the fraction. It's just faster. It's more about being efficient the more you're in math. Like change it, 15 divided by 3 is 5. Do you know what I'm saying? Like it's just faster, and then you're not dealing with bigger numbers, you know, like later on in the problem. So if you reduce like this whole thing to just straight up 5, then you're going to clear out the fraction on the other one. So you end up getting 25 equals x minus 3, and then you add 3, and then you're done. You know, like it's just so much faster. Yeah, otherwise you would distribute. Yep, exactly. But this is just faster. Again, it's all about being fast, honestly. Efficient, or like accurate, obviously, but also fast. So that's a thing. You can do that. Now, don't go wild, though, and start crossing off all this junk. Like, I've seen people do this and, like, cross out an X. That's like death. Okay? Don't do like that. That's illegal. So, if it's just straight numbers being divided. Okay, now this one's like kind of horrible, but it's like whatever, we'll be fine. This is just like distributing threw up everywhere. So you're going to take, I'll just throw these two. I'm going to multiply this beast. So just make sure you have parentheses. So you're still cross multiplying, it's just like horrible. It's not horrible, it's kind of satisfying. I like doing these, but it's like a lot of, you know, this is distributed. Just go with it. We don't know. Okay, so you're going to distribute, so you get 6, and then you're going to go 3 times 4 is 12x minus 8x. Yeah, negative, and then 4 times 4 is 16. X times x squared. Okay. And then this is just times 1. That was kind of a waste of time. Oh, and then you're like, oh my gosh, this is the best. Because it's a quadratic. Woo! You see it? X squared and an x. Oh, I can't wait. This is going to be so nostalgic and fun. So I'm going to combine like terms. Try not to mess up. Negatives freak me out, you know. So make sure you're combining like terms. I don't like that's, yeah, I could move it to the right. Or I could, I'm going to reorder it and change the sign. I'm not going to do that all at once though. I'm going to put the squared first. I'm going to move over the 6x. So it's negative 2x. And I'm moving over the 1. So I reordered it. Okay, there was nothing with squared I could put with. And then I put the 6x over here, so that'd be negative 2x. And then the 6 minus the 1 is 5. And then I don't like that. So I'm just going to divide out the negative. So like this is legal. You just like divide everything by -1 or multiply everything by -1. I don't know. Whatever your brain works for you. It doesn't matter as long as you get it right. So you get 16x squared plus 2x minus 5 equals 0. And then 16, come on. You know, like you. I think it's, I don't know. Is it factorable? If it's factorable, good for you. If it is, you can figure it out. I'm like, for me, I'm just going to quadratic it. So you don't have to. If you figured it out, good for you. But I don't want to do it. If I'm being honest here. So I'm going to throw in, I'm going to do quadratic formula. So -b plus or minus square root. So this is like a thing. You know, you could do quadratic formula is just going to creep in whenever you find it. So you're just going to throw it in quadratic, or if you figured out the factors, good for you. And I'm just going to go hardcore and simplify. Because what do I get? 4, and then minus a negative, so that'd be plus 320, right? Yeah. You think so? I don't like 16. I should be better about that. Oh, not 16. What's wrong with me? Okay, so I'm just simplifying my quadratic, just living my best life, you know. And you guys, this is like for the rest of your life, do what you think's easier. Like for quadratics. 16 over, ooh, oh yeah, dang it, yeah. All right, there she is. Okay, so the point of this problem is for you to realize, like, ew, you know, like they can be ugly. Okay, any questions? Okay. This one, ratio of measures of an angles of a triangle is 3, 4, 5. Find the measures of the angles. Okay, so I feel like don't overthink it, honestly. You're trying to figure out, they're all scaled by the same number, okay? So the way you set this up is you take, because it's 3, 4, 5, you're going to go 3x plus 4x plus 5x equals 180, because you're dealing with a triangle and angles. So angles in a triangle, that's all you do when they give you ratios like that. You just put an x with them because they're all scaled by the same amount. So you add those up, you get 12x equals 180. Yep, and then 15. And then is that it? No, of course not. Perfect. So to find, excuse me, the measures of all the angles, you just like plug it in. Do you have to label them, like A, B, or C? Not really, because they didn't really say anything. So you could just say 3 times 15, so one of them's 45. You know, 4 times 15, one of them is 60. And then 5 times 15, the other one's 75. So these are all the angles. Yeah, pretty much. I did 3x, so I did 315. Yeah. So if it was 2, 7, 8, it would be 2x plus 7x plus 8x equals 180. So if the number is different, you just put x with them. Sorry. Okay, this one, I mean, some of you could just figure this out without doing any much math with it. But 2 cities are 3.5 inches apart on a map and 1.5 inches, 50 miles. Find the actual distance. So this is like your generic scale problem. So what I do is I use the ratio. So a 1/2 inch is 250 miles. And then I just make sure my units match. That saves you in higher level math too. PS is the unit. So it says 3.5 inches, and they want to know what the actual distance is. So you're going to just do X miles on there. No, as long as you can get it, you're fine. So like some of you might be able to just do that in your head. But like if you did get like, because you know sometimes their scale is like annoying and ugly numbers. This is how you would set it up. And you would just cross multiply equals 50 times 3.5 is 175, and then double. Okay? Or you could say 1 inch is to 100 miles. You know? So it's kind of like lots of different ways. Okay? Okay, this one, when you're dealing with inches, this is why inches are dumb. I like metric stuff. So they're saying it's 7/8 of an inch, but you're given 1 inch is to 16 feet, so maybe that throws you with the fractions. Oh, the double. Do you guys know that? The double one means inches. Like the little dashes. I don't know if you know that, but just to be sure, that's what it is. So if you're going to find the actual dimensions of the bedroom, because they're just wondering, they just want the bedroom, just this guy. So we're going to do, maybe I'll do the length first. So they're saying 7/8 of an inch is to, we don't know, X feet. But we're given the scale 1 inch is to 16 feet. Okay? Now don't do your calculators. So obsessed with your calculators. The stuff in the later math, there's no calculator portions, okay? So like I want you to get used to this stuff. So like when you're cross multiplying, okay, 1 times X, that's easy, right? It's just X. But then you do 7/8 times 16. It's so easy, cross reduce. Do you know what I'm saying? Because 16 divided by 8. 2, right? So, like, you guys are, like, smart. Like, do it, you know? Definitely do it. Because you go 7 times 2, 14. Right? It's not that bad. Okay? And then if you do 5/8, like some of you already get kind of the pattern, so it's like 5/8 inch, oops, is to X feet, and then we use the same scale. Yeah. So again, when you cross multiply, you just get X and then cross reduce. You know, like use the fractions aren't bad if you know how to deal with them.
14 by like 10 or just regular or add.
Oh, you can just leave it. You can just be like this. Yeah. I don't want to deal with this. So I know some of you are in chemistry, but those of you who are not, this might be a little too much for you. But this is what they do. They use proportions for dosage for medicine. It's like constant. I got this from one of my friends, but I'm not going to do it. We'll be good. I want to get you guys some work time. So, the